Here, this is Vijayalakshmi Sugnali from WinMaths. In this concept or in this session, we have to discuss the questions on exercise problem 1.2. Already in last session, we have discussed one function, onto function, many one function, and based on their functions and definitions, solved some examples. Okay, here the exercise 1.2. The first question is that 1. Show that the function f from r star to r star defined by f of x is equals to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. Non-zero means other than 0. Okay, r star is the set of all non-zero real numbers means other than 0. All are have some quantity. Is the result true? If the domain r star is replaced by a natural number n with codomain being same as r star. Here first have to prove function f from r stars to r star. Okay, first have to consider domain and codomain. Here f of x is equals to condition or a function they given f of x is equals to 1 by x from r star to r star. Here r star is the domain and this r star indicates codomain. Here all the values other than 0. Whatever the values taken in domain as well as codomain as a other than zeros. Because when we put 0 in this place, then the 1 by 0 becomes infinity. The function is not defined. That's why other than 0 we have to substitute. Now codomain and domains are real number. Now first one set domain and here codomain. Then domain contain r star, codomain contain r star. Here is a function f. Clear? Here a function f. Now f of x is equals to 1 by x. If for example consider real numbers means all the numbers containing the real numbers. It may be rational number, irrational, natural number, whole number, even, odd, integer, whatever other than 0. Okay. For example, have to consider 1. We get result. Put x is equals to 1. Then 1 divided by 1 becomes 1. Okay. 1 is related to 1. Again, have to consider 2. Then we substitute x as 2. The answer becomes 1 by 2. That is 1 by 2. 2 is related to 1 by 2. So, whatever the values we have substituted, they are related with another real number. Hence, the given function is 1. Okay. Now, first condition, 1 1 condition. Have to return theoretically. Now, let us consider f of x1 is equals to f of x2. Here put x is equals to x1, that is 1 divided by x1 is equals to 1 divided by x2 for every x1 and x2 belongs to real numbers. Whatever the x1 and x2 values are taken, both are the real numbers in star. Okay. Now cross multiplication, x2 is equals to x1 forever x1 and x2 belongs to r star. Okay. Or x1 is equals to x2. This is the definition of 1 1 function. Hence it is 1. Hence it is 1 1. Now have to check the condition for onto. Here consider codomain part. Okay, consider the codomain part. Whatever the elements we have to taken as a real numbers. Okay, Here uh, put x is equals to 1, again we get the image 1. Put x is equals to 2, we get the image 1 by 2. Here 1 by 2 is also real number. Whatever the values we have taken in R star, we get the images. Therefore it is onto function. Have to written in a theoretical part onto. Let consider f of x is equals to 1 by x. Now for onto function, we have to replace f of x by y. Okay, y is equals to 1 by x. Again find the value of x. Take x is taken as here and y multiplication get divisible. Now the value of x is equals to 1 by y. So whatever the y value we have, we get the real number. For example, we get y is equals to 2, then x is equals to 1 by 2. 1 by 2 is a real number. Okay, then we have to substitute whatever the y value, then we get real number other than 0. Okay, which is belongs to real number. Okay, other than 0 badly whatever we give. Okay, 0 is not taken, that's why written as a except 0. It is written in the form of real number except 0, we get the real number. Therefore it is on. Okay, which is the proof. Because they given show that we are already shown here while taking example and as well as definition. Okay, the next question, what is that? In that question, is the result is true. The result is true for a function f from r star to r star. Again we have to check the result. We have to replace domain rx replaced by natural number and codomain being same. Now have to prove domain being same but codomain will be domain will be replaced by natural number but codomain will be same. Have to check for this second condition. Same function. Okay, that is a function f of x is equals to 1 by x. A function f from a domain. Here it is the domain. Here it is domain. Domain is replaced by natural number. Then codomain being same. That is asked. Okay, let's solve for this one. Now consider. Okay, now consider x being a natural number, codomain. Okay, here function r star, then domain will be natural number, here r star. Whatever the values taken here, all are natural number. Natural number means all the values are positive other than 0. Okay, the number starts with 1. 1, 2, 3, 4, 5 they given up to so on. Whatever the natural numbers we have taken. Here consider the function f of x is equals to 1 by x. Okay, now put x is equals to n. Here the first value 1 by 1, the value becomes 1. Put n value natural number to x is equals to 2, then 1 by 2, the value becomes 1 by 2. 1 is related with 1, 2 is related with 1 by 2. Put 3, x value becomes 3, then we get 1 by 3. Here put 1 is equals to 1, x value 1, x value becomes 2, x value becomes 3, up to so on for n values. Okay, all are real numbers. Okay, all are real numbers, hence it is 1 1 function. theoretically we have written 1 function. Okay, 1 function here. Let taken f of x1 is equals to f of x2. F of x1 is equals to f of x2. Again, f of x1 means 1 by x1, 1 by x2. Replace x1 is equals to x2 for every x1 and x2 are natural numbers, because x1 and x2, x3 up to so on, whatever the value we have taken as from the natural numbers, so x1 and x2 are natural numbers. Okay, then it is 1. Again, have to check for the onto condition. Okay, onto function. Here consider f of x is equals to 1 by x. Substitute f of x by y. Y is equals to 1 by x. Again solve for x. That's why taken x is equals to left side and y becomes divided 1 by y. Whatever the y values, okay, whatever the we substitute y values, then we get the natural number. Okay, but 1 by y is not a natural number. We have to substitute 1. Okay, 1 by 1 is natural number. Okay, again substitute y is equals to 1 by 2. 1 by 2 is natural number? Nothing. It is not a natural number. Then substitute y equals to 3. 3. It is not a 1 function. Onto function. Sorry. Onto function means every codomain has a image in domain. Here some values does not contain any images in codomain. So 1 by y not belongs to natural number. Okay, 1 by y is not belongs to natural number. Therefore, it is not onto. Okay, it is not onto. Therefore, the given function f from natural number to real number r star is 1 1, but not onto. 1 1 but not onto. Hence the proof. Okay, now have to solve for the next question. Question number 2. Okay, question number 2. Okay, now question number 2. Check the injectivity and surjectivity. Already we have discussed while defining the definitions. Injective means 1 1. Injective means 1 1. Surjective means onto. We remember this one. Okay, check the 1 1 and onto condition for the following functions. Now here have to observe range and domain and codomain. Here domain becomes natural number and codomain becomes natural number. So all the numbers are taken from 0 to infinity. The ray diagram is not necessity for all examples or while solving the problems, but starting it is necessity while studying the concept correctly, or some points are not missing here. Okay, it is necessity. Is there starting first? It is natural number. It is natural number. So number starts with 1, 2, 3, 4, 5 up to so on. 1, 2, 3, 4, 5 up to so on. Then let f of x is equals to x square. Have to consider f of x is equals to x square. Now check the condition. Now have to substitute x is equals to 1 because the natural number starts from 1. We get 1 is equals to 1 square, that is 1. Put x is equals to 2. 2 square means 4. Then f of x is equals to 3. It is 9. Now when we substitute 1, we get 1. When we substitute x is equals to 2, we get 4, 3. It will goes on. Here consider f of x1 is equals to f of x2. Okay, f of x1 is equals to f of x2. f of x1, substitute x is equals to x1 in this function, x1 square, okay, is equals to, substitute again x is equals to x2, it means x2 square. So x1 is equals to, taking square on this side, that will becomes square root, x square whole root. 2 and square get cancelled. x1 is equals to plus or minus x2. x1 is equals to x2 or x1 is equals to minus x2. Here we have to taken as a domain as well as codomain, means natural numbers. Hence natural numbers starts from 1 to infinity and all natural numbers are positive numbers. Hence we have to neglect it. Okay, we have to neglect it. Therefore for natural number have to consider x1 is equals to x2. This is the result. Hence a function f from n tends to n is 1 function. Therefore it is 1. Again check for the condition and, okay, again check for the condition and let consider f of x is equals to x square. Again substitute f of x by y is equals to x square. We get the x value, okay, or solve for x, then x square is equals to y, then x is equals to plus or minus root y, okay, plus or minus root y. Whatever we have substitute the value y, we get the x1. If for example have to substitute y as a 1, then root 1 will be plus or minus 1, okay. Hence we consider the point, that's why 1 is possible, but for 2, root 2 is not a natural number. The value root 2 is not a natural number, that's why, because whatever the codomain is also natural number, their image should be a natural number, but when we substitute 2 codomain value in this function, we doesn't get the image for x. Hence y does not belongs to n. Therefore it is not onto. Hence it is not onto. Therefore a function f from n tends to n for f of x is equals to x square is 1 but not onto, okay. This is 1 function but not onto function. Again check for the second conditions. The function f from integer to integer given by f of x is equals to x square. Okay, now integer. Integer means the numbers contain 0 plus or minus values. Okay, 0, minus 1, minus 2, minus 3 up to so on, plus 1, plus 2, 3 up to so on. Here also 0, minus 1, minus 2, minus 3, again 1, 2, 3. Okay, now check the condition. F of x is equals to x square. Okay, now check for 1 condition. Let f of x is equals to x square. Again for 1 condition, taking f of x1 is equals to f of x2. x1 is equals to x1 square. Then x2 is equals to x2 square. Again x1 is equals to square root of x2 square. Square root get cancelled. Here x1 is equals to plus or minus x2. x1 is equals to x2 or x1 is equals to minus x2. x1 is equals to x2 or x1 is equals to minus x2. Okay, when we substitute x1 is equals to 1 value, then x2 sometimes it is positive number, sometimes it is negative. For example, while checking, substitute x is equals to 0, we get image 0. Okay, f of x is equals to 0, we get the image 0. Again substitute minus 1. Okay, substitute x is equals to minus 1, we get minus 1 square. Minus into minus, plus 1 into 1, 1. Okay, minus 1 square, the value becomes 1. Again substitute 1, so 1 square becomes 1. Similarly, minus x2, minus into minus, plus 2 square means 4. Again for 2, here it is not 1 function. 1 function, because if two values having one image. Okay, 1 condition means every distinct element has a distinct image in domain. Here one value has two values having the same image, therefore it is not a 1 function. Again checking onto function. Let f of x is equals to x square. Again substitute f of x is equals to y. Y is x square. F of x is replaced by y. Y equals to x square. Then we get or solve for x. X is equals to plus or minus root 5. Okay, whatever the we have taken values. Okay, whatever the values, if we have put y is equals to 1, we get plus 1 or minus 1. It is a integer. Okay, then put y is equals to 2, root 2. Root 2 is not a integer. Okay, root 2 is not a integer, hence which is not a onto function. Root 2 is not a integer, therefore it is not onto. It is not onto function. Therefore a function f from z tends to z given by f of z is equals to z square is neither 1 nor onto. Okay, next question number 3. a function f from r tends to r given by f of x is equals to x square. This one is present in examples questions. Now, while checking this one, consider function. Consider function f of x is equals to x square. Now, check the 1 condition. Okay, 1 condition. Now, f of x1 is equals to f of x2. Okay, f of x1 is equals to f of x2. Here, substitute x1 is equals to x. That's why then x1 square. Again, substitute x is equals to x2. We get x2 square. x1 square, x1 is equals to square root of x2 whole square. Square root and square will get cancelled. x1 is equals to plus or minus x2, or x1 is equals to x2, x1 is equals to minus x2 for whatever the x1 and x2 value becomes real numbers. Okay, whatever the x1 and x2 values are taken here, all are real number. While checking the condition by using the domain and codomain. Here, consider the domain. Both are real numbers. Whatever the real numbers we have taken, we get again a real number. Substitute x1. For example, real number 1, 2, 3, 4 up to so on. Again, it may be 1, 2, 3, 4, 5 up to so on. Plus values is there, negative values is there, point values are taken. Whatever we have taken, all are real numbers here. Now, while taking x1 is equals to x2, it get 1. Okay. Then, while x1 is considered, x1 is equals to 1, then it may be minus 1 also. Okay, it is minus 1. For example, 1, 2, 3, 4, when we substitute minus 1 here for real numbers, minus 1 whole square will be plus 1. Plus 1 is also real number. Okay, minus 1 square means plus 1. Then again, for 2, 2 is real number. 2 square will be plus 4. Again, while taking minus 2. Minus 2 is also real number. Taking minus 2 square, then we get the value 4. Okay, whatever the real numbers taken, we get the one or more than one image. That's why 1 and minus 1 has the image 1. Therefore, x1 is equals to plus x1, or x1 is equals to minus x2. x1 has two values. Therefore, x1 not has unique image. Okay, x1 does not have unique image. Therefore, function is not a 1. F is not 1. Therefore, f is not 1. While checking onto condition. Okay, while checking onto condition, here f of x is equals to x square. Okay, substitute or replace f of x by y. Y is equals to x square. Solve for x. X is equals to plus or minus root y. Whatever the values, okay, whatever the values we have taken, all are real numbers. Okay, all are real numbers. We get 1. Okay, we taken as a 1. Then it is a real value. Again, 0.2. Okay, the value becomes 0.4. Okay, then it is also real number. Now taking y value becomes negative, that is x is equals to plus or minus root of minus 3. Root of negative values, that is imaginary. Okay, that is imaginary. For example, I value becomes root of minus 1. Whatever the values negative of real numbers taken as y, we doesn't get again real number which is not belongs to real number. Okay, for this condition it is not onto. Therefore, a function f from real number to real number given by f of x is equals to x square is neither 1 1 nor onto, neither 1 1 nor onto. Again have to check the next condition. Again have to check the next condition or next problem. A function f from natural number to natural number given by, here the function is taken as a f of x is equals to x cube. In last function we have taken f of x is equals to x square. Here f of x is equals to x cube. Now domain and codomain are natural numbers taken. Okay, now first f of x is equals to x cube. Here for 1 1 condition, let f of x1 is equals to f of x2. Okay, again x1 is equals to x1 cube, x2 is equals to x2 cube, x1 is equals to x2 cube of cube root. Cube root and square root will get cancelled. x1 is equals to x2. Whatever the values we have taken, we get the x2. Okay, for example, when we taken 2 cube, okay, then it is multiplied by 2 into 2 into 2. Here taken as a minus 2 cube, that is minus 2 into minus 2 into minus 2. Okay, minus into minus, minus, minus into minus, minus into minus, plus, plus into minus, minus, 2 into 2 4, 4 into 2 8. The negative values of cube root is negative values. The positive values of cube root is always positive. Cube root of positive value will be positive and cube root of negative value becomes negative. Here while taking the natural number, we get the natural number because natural number contain a positive values. Okay, for example 1 2 3 4 5 up to so on. For n is equals to 1, 1 cube becomes 1. For n is equals to 2, 2 cube becomes 8. Again for consider 3, 3 cube becomes 27. Now f of x is 1 1. F is 1 1. Here whatever the values taken, okay, for example x1 is equals to 1, then put here x is equals to 1, 1 cube, 1 cube becomes 1. For 2, 2 cube value becomes 8, while 3, 3 cube 27. 4, 4 cube means 4 4s are 16, 16 4s are 64. Okay, whatever we have taken all are the positive numbers. Again let f of x is equals to y. Okay, f of x is equals to x cube. Again replace f of x by y, we get x cube. Then solve for x is equals to cube root of y. X is equals to cube root of y. Whatever the values we have taken, all the values becomes cube root of y. But cube root of y does not have a natural number. Okay, cube root of y, whatever the y value taken, they are not a natural numbers. Therefore, f is not. Sorry, f is not onto. F is not onto function. Therefore, f is 1 1, but not onto for function f from n tends to n given by f of x is equals to x cube. Okay. Now, the second one function. A function f from z tends to z, integer to integer, given by f of x is equals to x cube. Okay. Here, first f of x is equals to x cube. Okay. Now, solve for f11 function. Here 1 1 integers containing positive negative values. Okay, 0 minus 1 minus 2 plus 1 plus 2. Okay, this is also integer, this is also integer. Now f of x1 is equals to f of x2. Again x1 becomes x1 cube and f of x2 is equals to x2 cube. x1 cube is equals to x2 cube means x1 is equals to cube root of x2 cube. Square root and cube root and cube get cancelled. x1 is equals to x2. Okay. For example, while taking negative values, minus 1 cube we get minus 1. Then 0 cube 0. Minus 2 cube, that is minus 8. Again 1 cube 1, 2 cube 8. Whatever the values we have taken, we get the image. Distinct element has a distinct image. Therefore, f is 1 1. Again, check for onto condition. F of x is equals to y. Y is equals to x cube. Solve for x. X is equals to plus on the cube root of y. Okay. Whatever the consider of y values, we get cube root of that number. Cube root of any number doesn't exist in integer. Okay, does not exist in integer set. Therefore, a function f is not onto. F is not onto. Here, whatever the value we have taken for y, we doesn't get any integer value for x. Okay, hence f is not onto. Therefore, the function is 1 1, but not onto for the function f from z tends to z given by f of x is equals to x cube. Okay, now again discuss next problems on next section. Thank you.